Hello everyone, this is Brian with EnGenius Technologies. I want to thank everybody for joining us today. This is probably one of the largest webinars we've have done in a couple of months. So we appreciate everybody's time for joining us talking about 11AX. We actually have a special guest with us from Qualcomm Theros, which is Simon Brand. He's the Senior Director of Product Management for Qualcomm Theros Incorporated. So we'll be able to have him speak in regards to 11AX specifically. So with that said, let me begin really quickly. There we go. And Simon, I will unmute you. Hi, Simon, are you there?
Yes, I can hear you, Brian.
Oh, perfect. So I want to thank you for joining us today, and we look forward to your presentation on 11AX and the features of Wi-Fi 6, I guess I can say now, or should say. So we look forward to that. So with that said, I'll go ahead and begin. I first wanted to talk about EnGenius just really quickly. We have a lot of new attendees to this particular webinar, but EnGenius has really been around for about 19 years. We're coming up on 20 years in April of next year. We have a lot of experience in business class networking solutions, and we serve the SMB market. We're actually located in Orange County, California. EnGenius really pioneered long-range, high-powered wireless communication and RF frequency solutions in the late 1990s. And actually, we continue that legacy through our brand portfolio of business, or broad portfolio of business class networking and telephony solutions. Our portfolio of networking solutions includes a full line of managed and unmanaged wireless solutions and gigabit switches. And we're still delivering that long-range connectivity that a lot of our partners are used to. We have very robust feature sets that provide a lot of versatility. We have probably one of the highest price performance values in the market today. So what we'll discuss today is the demands on Wi-Fi. You know, it's a really exciting time for the wireless industry. There's so many different uses for Wi-Fi. When I started maybe 15 years ago, when we were using 802.11b, there wasn't a lot of adoption. That adoption has increased dramatically, and so we'll talk about the demands of Wi-Fi. We'll then have Simon speak a little bit about the Wi-Fi 6 or 802.11ax technology, and he'll go into the different features that will be offered in 11AX in general and specifically in the EnGenius product. And then we'll discuss the EnGenius 11AX access points at the end of the presentation. So when designing an SMB network, we typically design for 2.5 wireless devices per user. The number of wireless devices in an environment is dramatically growing. So general applications, our field applications engineers, our design team typically say per user there's about 2.5 Wi-Fi devices. In higher capacity situations, we see anywhere from 3 to 4 devices per user, and that's wireless users. There was a study that went out, was done by Cisco V&I, that the number of devices per user is growing rapidly. And this is connected devices, not necessarily wireless devices, but connected devices per user is growing. And in 2017, they measured 8, and by 2021, there will be 13 connected devices per person on your network. So these are the things that we run into on a daily basis. Some of the questions that we're asked when we design networks is, okay, what is the wireless client capacity that we have to support within this network? And that's always been a challenge, and that continues to grow more and more every day. And so we see that a lot. Another thing that we have to consider is not only what each person is carrying with them or connecting to the network, but the IoT market. The IoT device market is rapidly growing as we can start to think about smart homes, smart offices, smart hospitals, smart schools. All these IoT devices are connecting using different technologies, but a majority of it will be Wi-Fi. IDC reported 30 billion devices by 2020 and 80 billion devices by 2025. Cisco Visual Network Index reported machine-to-machine connections will grow 2.5 times, and it will be the fastest growth that we'll see in regards to connected IoT devices. Then you have smartphones will grow in second fastest, and that will be about 9%. Excuse me. And then connected TVs, for example, will grow at third, about 7%. So there's huge growth within the IoT industry. So now, as a wireless LAN professional or designing your networks, you have to now consider, okay, the individual user has X amount of devices per them, and then we have to also consider all the smart devices that are going to be out there. Gartner is of the same opinion and declared that by 2020, 95% of the electronics will be IoT enabled. So there's huge growth and demand that will happen on the Wi-Fi network. So client device or clients or Wi-Fi clients is one demand. That's a major demand, and we're seeing major growth in those areas. But another demand is within the bandwidth territory. And there's more and more devices that rely on Wi-Fi. There's a lot of offloading from the cellular traffic from tablets and smartphones. There's a lot of implementation and into applications where there's avoidance for wiring because of the cost of running wire. There was a study done that gave a cost of $660 per household when you think about a residential kind of application. And the business application, $2,000 per building. So the avoidance of having that extra cost, they're using Wi-Fi. IoT connectivity, which we already talked about, that's another portion of that bandwidth demand that we're looking at. And just the convenience of Wi-Fi, having that convenience of not running wire and having a device anywhere within a business, within a residential space, and it being Wi-Fi, just that convenience in itself is a huge bonus. Forrester Research has predicted that IoT will become the backbone of customer value as it continues to grow. So this is a huge demand that we have to look at also. You can see the current average Wi-Fi speed is 37 megabits per second and will quickly go up to 73 megabits per second or 74 megabits per second, and it grows through the year. So there's a huge demand there for more speed. Growth in Wi-Fi and mobile traffic in relation to traffic from wired devices by 2020, there's rapid growth there also. So if I look at wired and wireless traffic, in 2017, traffic breakdown between wired and wireless was wired traffic was about 48%, and wireless traffic, meaning cellular and Wi-Fi, was about 52%. By 2022, the traffic breakdown in regards to wired traffic will be about 29%, wireless traffic will be 71%. And this was presented also by Cisco VNI. So rapid demand in both in the number of connected devices and bandwidth. The things that we have to look at EnGenius when we're working with customers and deployments is how the bandwidth is being used, what applications are being used. And when you look at it from a smartphone or a tablet situation, these applications are driving higher demand on the Wi-Fi network. Wireless users spend 53% of their communication time connected to Wi-Fi networks. And so we have to be ready for this demand. And what do we do to get ready for this demand? How do we meet the demand for number of connections and bandwidth? So Wi-Fi 6 fundamentals. Wi-Fi 6 is one of those things to meet those demands. One of the primary things for Wi-Fi to meet those demands. And we're very happy to have Simon Brand on today's webinar. He's the Senior Director of Product Management, Qualcomm Incorporated. Qualcomm is a leader in chipset design and manufacturing. Qualcomm is used in all of our high-end quality wireless devices, and we're very happy to welcome Simon Brand today. Welcome to the webinar, Simon.
Hi, Brian. Yeah, thanks for giving me the opportunity to explain Wi-Fi 6. So if you can go to the first slide of my presentation, this is the next one. I list the capabilities that I brought in through 11ax to improve the use case. So 11ax has been designed to get a factor 4 higher throughput in very dense environment. So there are a few elements that contribute to a factor 4 higher throughput, and I will go through these. So the first element that contributes to this is the longer OFDM symbol. So in Wi-Fi, data communication happens in bursts of data. We call these OFDM symbols, listed in the light pink part on the left picture. You can see also a dark pink area, which is the guard band. So the payload is really in the light pink area. So you can see in 11AC that if you concatenate these buckets of data, that the payload is so if you put these together, the dark purple area is taking about 20% of the time. If you go to the long symbol in 11ax, the payload is longer, and the guard band, the dark purple area, is smaller. So that gives about a 20% higher throughput, simply because of the let's say the longer OFDM symbol. What 11ax also offers is to increase the guard band, so the dark purple area is getting a little larger. Which enables outdoor deployment. You have to give up a little bit of throughput, but the longer symbol makes outdoor deployment more robust. So the other thing that comes in 11ax is 1024 QAM. So if you have in-room communication, you're able to increase the amplitude modulation rate. That gives an additional 25% higher throughput rate. So the combination of these two gives about 40 to 45% higher throughput rate. Another element that comes in 11ax is the ability to have 8x8 access points. 8x8 access point will give 8 antennas, and 8 antennas will give the ability to have the aggregation of spatial streams of the stations. We call that multi-user MIMO. And that will increase the capacity. Also, the 8 antennas on an AP will give better precision for beamforming to reach further to a specific station that is served by the access point. So then we come to new protocols like OFDMA. So OFDMA is a technology that takes the 80 megahertz spectrum, for example, and chops it up in smaller units of let's say 2 megahertz each. We call that resource units. And these resource units can be allocated per user. So if one 80 megahertz transmission happens, it contains multiple users that each get a certain subset of that 80 megahertz. That enables higher efficiency, especially for small packet traffic. So if, for example, you have enterprise voice, if you have control packets, these will typically go out on an OFDMA modulation technique. And this is available in both the downlink as well as the uplink direction. There is also a possibility to take that small bandwidth and concentrate all the energy of the station in that, let's say, 2 megahertz RU, which will result in a longer range. So we can expect, especially in the uplink direction, to have let's say, an improved range feature. So then the other technology is multi-user MIMO. So multi-user MIMO enables, as I said, the aggregation of spatial streams up to the amount of antennas. This is offered in both downlink and uplink direction. This modulation technique is typically chosen by the AP to, let's say, if large packet transfer are happening. So another feature coming in 11ax is extended range. There is an ability to boost the preamble by about 3 dB, not increasing the overall energy of the packet. We stay below the ARP limit. By having repetition schemes following the preamble, we are able to reach about a 3 dB improvement in range on top of the other features that exist. So then there is a BSS color feature of it. So BSS color is a 6-bit random code that is part of the preamble of every packet that is being transmitted by either AP or station, and that color is seen by other access point or stations in the let's say in the area, and if the power is low enough of that receiving packet, the AP in this case will be able to transmit right over it. And will not wait for the packet to finish. So in a very dense environment where you have a lot of OBSS, so neighbor APs, let's say the probability to transmit is higher, and therefore more transmissions will happen in a very dense environment, contributing to the 4 times higher throughput. And then the last part is that that 11ax is specified to be used both in 2.4 and 5 GHz. So the Wi-Fi Alliance will certify these 2 radios. Whereas in 11ac, the technology was only designed for use in 5 GHz, not in 2.4. So it will cover all bands. So you can go to the next slide, Brian. So in this slide, I show a little bit of the numerology that I spoke about in the previous slide. So in 11ac, so the dark blue area is the guard interval that I talked about. So that is where no data is transmitted. But in the light blue area, that is called 11ac data, 3.2 microseconds, is where the payload resides in 11ac. And that results in 433 megabits per second per antenna. So if you go to the 11ax symbol format, the top row shows a payload of 12.8 microseconds. That is the 4 times longer guard band, the longer payload. And you can see that the guard band is 0.8 microseconds in this example. So that results in an overall throughput rate of 600 megabit per second. So that is about a 39 to 40% increase in throughput rate. And as I explained, the guard band can be increased to 2x GI or 4x GI in case of outdoor employment where multipath echoes have to be dealt with. So you give up a little bit of throughput, but you will have improved performance in these multipath environments that typically are outdoor. So I go to the next slide, Brian. So here I show the improvement that can be expected by transitioning from 11ac to 11ax. So I show here 2 graphs. The left graph is the performance expected in the 5 gigahertz band in a 4x4 antenna product, and the graph on the right shows the throughput that is achieved in a 4 antenna system in the 2.4 gigahertz band. So you can see that in both cases the max throughput rate at short distance is going up from 1300 to about 1800 megabits per second in best case UDP performance. So that gives you the 39%, and in mid-range, if you on the horizontal axis we show the distance from the station to the AP. So in mid-range, you can expect to achieve the same bit rate as in 11ac at about 6 dB further distance from the access point. So in an in-home environment, you typically are able to move behind one extra wall to and get the same throughput rate as in 11ac, and that is true for both 5 gig as well as the 2.4 gig band. So go to the next slide, Brian. So in this slide, I show a little bit better how multi-user OFDMA is, let's say, is benefiting the user versus multi-user MIMO. So imagine that an access point will get the packets, the flows coming in from the Ethernet pipe, the WAN pipe, and then the scheduler, the Wi-Fi scheduler, has to decide to pick either one of these modulation technologies to get the data across. So in this example on the left, we show that if a mobile phone that, for example, has 2 antennas, so it's a 2x2 product, will have small data traffic, then not the full 80 MHz band will be used, but the gray phone will only occupy a subset of the 80 MHz capacity in a resource unit, and the green phone may have a little bigger buffer traffic, so it will take a little bigger part of the 80 MHz spectrum, and together one packet will be transmitted to serve those two clients. So on the right hand side, if a phone or a device, a connected device in let's say in the office space or in the home has a lot of data traffic to be transmitted, you can think about video traffic or about mobile devices that do an upload to the cloud. In that case, you want to use the full 80 MHz bandwidth, and then you make use of the multi-user MIMO capability to stack the full 80 MHz spectrum on top of each other up to reaching the number of antennas of the access point. So in case of 8 antenna, you're able to aggregate up to 8 full 80 MHz bandwidth. In case of a 4 antenna product, you will do that up to 4, and in case of a 2 antenna product, you will be able to aggregate up to 2 spatial streams. So the AP is really in control to pick either one of these modulation techniques, dependent on the type of traffic that is to be served. And in Qualcomm's product, we deliver a high-end scheduler that will be able to distinguish which is best for, let's say, for that specific use case at that time. So I can go to the next slide, Brian. So here I show in an let's say in another way the MU MIMO capacity increase. If you compare 11AC on the left-hand side, you can see that in 11AC the multi-user MIMO capabilities is only there for the downlink part. So assuming that every phone has 1 antenna, has a 433 capacity radio. In the downlink, we're able to aggregate up to 4 of those streams to 1733, and in the uplink, since there is no MU MIMO capabilities, that is just 1 phone at a time, reaching 433 megabit. So if you go to the right-hand side, we spoke about the 600 megabits per second capacity that 1 antenna will reach in 11ax technology. If you aggregate 8 of those 1 antenna devices, you get a little over 4800 megabits per second. And this capacity through MU MIMO will be available in both up and downlink. In case of an 8 antenna system, and in case of 4 antenna, this is 2402 megabits per second in either uplink and downlink. Okay, you can go to the next slide, Brian. So in this slide, I'm showing TWT. So TWT stands for target wake time. So what does it mean? So in the top slide, I show how the communication happens without the TWT feature, and in the bottom part of the slide, I show the communication where TWT is enabled. So I see that there is a small mistake on the slide. So the bottom part should be with TWT rather than no TWT. So let's go to the top part of the slide first. So in case there is no TWT feature, what happens if an AP and a station communicate? The actual communication happens in the orange section, so either a receive or a transmit of packet will occur, and the station will consume power in that case. And then in the interval in between the actual transmission, the station will have to listen, and listening consumes power, right? So in the white area, the battery is drained for kind of no reason. So then what TWT is offering, so in the bottom part of the picture where TWT is enabled, there is an agreement between the access point and the station, where the station know when the access point will be ready to receive or transmit data from the station. So that means that in the inactive periods, the station can go to sleep, will not consume any power from a Wi-Fi radio perspective. And then at the time the scheduled access is occurring, the Wi-Fi radio of the mobile phone wakes up and is doing the receive or transmit of that packet, and then goes back to sleep. And it is guaranteed that the AP will be able to communicate to that station. So in that way, we improve the battery life of the station devices. So this can be used for mobile phones. It can be used for IoT devices, as Brian mentioned. So battery-operated devices in general will benefit from this. So Brian, I think this was my last slide, right? So if you go to the next slide, it shows the end of the presentation. So this is my contribution.
Yeah, thank you so much, Simon. That was great information. I think, I didn't mention this, but I have Eddie and Gabriel, who are both on our field applications engineers and our product management team. And yeah, we're learning a lot as we've learned a lot from this presentation. So thank you very much, and hopefully the audience learned a lot from that. And I didn't mention this at the beginning, but we will save questions at the end. And I believe, Simon, you're staying on until the end and help us answer some of the questions that some of our end users may have.
Sure, I will.
Perfect. So, EnGenius 11AX access points. So, what we want to do to meet the demands of IoT devices, the number of clients per person, the bandwidth needed in these situations, EnGenius has launched 2 access points specifically to provide that greater capacity, to provide that stronger connection, and to provide future capabilities. The new 802.11ax technology, or Wi-Fi 6, was really built upon real-world deployment of 11AC. And so what we wanted to do is bring that to the forefront within the SMB market. So we're taking a technology that was designed to address demands for high capacity on really enterprise networks and deepens and strengthens wireless capabilities for more users. We took that stronger, steadier, and more efficient 802.11ax, which enables, like Simon was mentioning, more efficient channel use, reduced latency between APs and client devices, and provides other groundbreaking features. We wanted to provide that to, or put that next generation cutting edge technology to forward-thinking SMBs. We want to fast track forward-thinking SMBs to take advantage of some of the most sophisticated wireless technology to date. So early adopters won't have to wait to take advantage of this technology and features. And so that is EnGenius's role, and what we've done is launched first, the industry's first 11AX 2x2 access point. That access point fulfills the Wi-Fi connectivity demands for small and mid-sized organizations. We really wanted to match the needs of the majority of today's clients, which are typically 1x1 and 2x2. A majority of the mobile devices are a 2x2 design and a 1x1 design. Some of the newest phones that are out there are only using MIMO. They're not even single-user MIMO. They're not using multi-user MIMO. We want to enable advancements within the network without demanding a significant restructuring of their current network. So these devices will go right into the network without any switch upgrades to the current network. It supports existing and future devices and applicable needs or application needs. It's, as Simon mentioned, it's backwards compatible with legacy Wi-Fi. It's hard to say that AC is legacy, but it does support A, B, G, and AC. And it re-energizes really the capacity reach of 2.4 and 5 gigahertz. That 2x2 is EnGenius's part number, the EWS 357AP. That is the part number. It will retail at a $189 price point. It's a ceiling mount. It will be manageable. It will be manageable in a number of different ways. It would be manageable by our layer 2 switch, which is acting as a controller. It can be managed by our private cloud or our cloud service that sits on AWS. That really depends on the need of the customer and the application needs. Obviously, it supports all of the standards of Wi-Fi. It will provide up to 1,200 megabits or 1.2 megabits on 5 gigahertz and 574 megabits on 2.4. Again, it's a 2x2, 3 dBi antenna design. It has one Ethernet port that provides a gigabit port. It does have an adjustable 20 dBm radio inside of the device, so you can choose the turn down power or increase the power depending on the needs of the application. The device surprisingly only consumes at max 12.5 watts of power, so that's a big deal. And it will support WPA2 and the new security WPA3. So it will support the newest and latest wireless security. And again, as I mentioned, it can be configured, managed, and monitored with our network management software called EasyMaster, which provides things like captive portal, guest networking, there's seamless roaming that's built in, there's bandwidth control per SSID per user. So there's a lot of features within our access points that, that you can gain from these devices or these access points. We will also have a 11AX 4x4 access point for those really high density applications. And we'll talk about a little bit about the applications near the end, just to give you an idea of where these devices would go into. So the 4x4 access point really meets the needs of today's and actually future high density client device applications, which is obviously becoming more relevant. Anybody that goes online that searches IoT devices, you'll quickly find the growth projections on those. The number of clients per user, you'll see the projections of how those numbers are growing, and obviously the requirements on bandwidth also. So it will enable SMB customers with a solution for those high concentrated Wi-Fi areas, such as large training rooms. So we'll have a mixture. So one application could have our 2x2 design and also our 4x4 design. I should also mention at this point that we will have an 8x8 design come later next year. The 2x2 and the 4x4 will launch, units will ship, I should say, not launch, ship in January. So take note of that. So again, it will support existing and future device application needs. Again, it will be backwards compatible, and also it does re-energize the capacity and reach of 2.4 and 5 gigahertz frequencies. A little spec info on the EWS 377AP, which is that 4x4 that we're talking about for the high client density applications. Again, it's a managed ceiling mount access point. It supports AC, AGN, and AX. It's providing, in regards to theoretical speeds, 2.4 gigabits on 5 gigahertz and 1.1, 1.2, somewhere around there on 2.4 gigahertz. Again, this is a 4x4 antenna design. There are 3 dBi antenna gains on those particular devices, all internal, obviously. This has a single port, but it's 2.5 gig port for this particular device. Obviously, it's an auto sensing port. It has an adjustable 23 dBm radio, so you can adjust the power even higher if you need to, or lower if you need to. This particular access point only supports, only the power consumption is only 17.5 watts for this particular device. It will also support WPA2 and WPA3 wireless security within this particular access point. The form factor will be very similar from the 357 to the 377, or the 2x2 to the 4x4. We'll have a Kingston lock, LEDs. The mounting's changing up a little bit where it'll slide into place. Obviously, we'll provide the reset button, DC jack, and RJ45 ports for these particular devices. But for the 357 and the 377, the form factor will be very, very similar. It may be a little bit thicker, and then on the 8x8 might be a little bit thicker because of the number of antennas that we have to add within the device itself. Some of the applications that you'll see with the EWS 357AP access points, and this is the applications that we run into today, and this is where we see that these devices will fall. So example, 2x2 could fall anywhere from a large home to a business office, to assisted living, to K-12 or a private school, car dealerships, smart homes, classrooms, hotel rooms, whereas the EWS 377AP, which is a 4x4 design, will go into higher capacity situations like large conference rooms, community colleges and universities, commercial AV, large training rooms, auditoriums, school cafeterias. So the higher the density, will depend on what model you'll use, and you'll be able to use these devices interchangeably in these different applications. And again, these devices are manageable. They're manageable by multiple ways. You can actually mass configure these devices, or you can manage these devices in groups. There's a number of ways that you can manage these devices with the EnGenius tools that we have. So at this point, what I'd like to do is open it up for any questions that you may have. If you would like to email us in regards to this presentation and or have questions in regards to the product that we have for 11AX and or questions for Simon, you can email us at partners@engeniustech.com. But feel free, if you have any questions, this is the time to ask. Okay. Okay, so this is a great question for Simon. Simon, is multi-user OFDMA and TWT enabled by default, or does it need to be enabled only where supported?
The feature is enabled by default, and the scheduler will decide. So the way it works is that the AP has all the capabilities, and then it will negotiate with the station whether what are the capabilities of the station, and then it may decide to use these, let's say MU OFDMA in this case, if the station has that capability. So in the PPDU that goes out, OFDMA will be used by default, and if it talks to an 11AC device, it will stick to 11AC communication.
Thank you, Simon. Another question: with 12.5 watts of power consumption, is it 802.3AF compliant or 3AF?
Yeah. Yes, this is for 802.3AF. Yeah, for 12.5 watt. But for 4x4 AP, 17.5 watt will be 802.3AT.
Another question is, I think we answered this question, but is PoE supported? Yes, it is supported. That seems to be a lot of the questions about PoE. So both these devices are PoE compliant. The EWS 357 AP is 802.3AF compliant. The EWS 377 AP is 802.3AT compliant. So yes, they are both compliant. Products will be shipping in January. I would say mid-January, maybe mid to end January. Both the EWS 357 AP and the EWS 377 AP will be shipping in January. We'll have limited supply, but we have a great launch promotion that will happen in January, so stay tuned for that particular promotion. But yes, they will be available in January. So here's another great question for Simon. Hopefully you can help with this question. How will mixed 802.11n AX client devices impact the overall performance of 802.11ax networks?
Sure, I can answer that. So the way Wi-Fi works is that there are transmit opportunities. Let's say every 2 milliseconds, typically a PPDU goes into the air, and that is either 11N, 11B, 11AC. So with the 11AX technology, so the more clients are 11AX capable, means that the more efficient the communication will happen to those 11AX clients. So that will result in less airtime needed to get the data across to those devices, and more airtime will be available for the legacy devices. So dependent on the mix of the amount of 11N, the amount of 11X clients, everyone will benefit from it. So over time, with more 11AX deployment, even legacy devices will benefit more.
Thanks, Simon. Is the management software Mac and PC friendly?
So yeah, EasyMaster you can reside on the PC or any Linux-based as long as EasyMaster is going to run on the virtual machine, like a virtual box of VMware. So you can reside on a PC or Mac or even Linux systems.
Thank you, Eddie. Simon, this might be another question for you. Are there any benefits for 11AC stations connecting to 11AX APs? What answer that to?
Yeah, so when an 11AX station connects to an 11AX AP, the 11AX AP will recognize that it is an 11AC station, and it will communicate through the 11AC protocol. Of course, 11AX has been designed for 1024 QAM, has better sensitivity. So that means that because of the improved, let's say, RF capabilities, RF performance, the 11AC client will see better performance, especially on the let's say on the EVM, the transmit EVM, and on the receive sensitivity. So there is a kind of a residual benefit in the Qualcomm products for 11AC clients in terms of higher amplitude capabilities within the capabilities of 11AC. So there is a higher probability MCS9 will be chosen compared to existing products due to better RF in our products.
Thank you, Simon. I'd like to add to that. So typically, yeah, so when we deploy a new product, I mean, we're refreshing the whole product, the system board, all the components on the system board, memory, flash, CPU, the latest and greatest chipset, refresh across the board. So traditionally, we've seen major improvements with just the hardware refresh with all clients. Just to give you an example of that. So when we launched 11AC, we have a 11AC 3x3 access point that performs really well. When we launched our 11AC Wave 2 2x2 antenna, not a 3x3, but a 2x2 antenna, we saw gains of about 30%. So we already saw improvements just based off of the component refresh that we do on our system boards and the latest and greatest components that we were using. So you will see an advancement right off the bat. You'll see a further advancement once the client devices become, once you see more and more 11AX client devices. Here's another great question for Simon. Are there any client devices of 802.11ax, or when can we expect 802.11ax client devices?
So typically the infrastructure is the first to be ready for the deployment of 11AX devices. We envision that in 2019 the first 11AX stations will become available. whereas the infrastructure is prepared for that.
Thank you. Okay. Another question, you may have kind of answered this, but will TWT work with 802.11n and 11AC client devices? Simon, that's a question for you, sorry.
Sorry, I missed that question. Can you repeat?
That's okay. I didn't prompt you.
Yeah, I didn't have my name. Sorry, I was not paying attention.
Will TWT work with 802.11n and AC client devices?
No. Both AP and station will need to have the ability to understand each other. So that means that 11N devices will not benefit from it.
Thanks, Simon.
Yeah, so there is one let's say one exception here. So Qualcomm has a station product which is the 3998, and that product will have the let's say the TWT capabilities that will be coming to the market in products let's say early next year.
Perfect. Thank you. So I think that's all the time that we have. We appreciate the questions. There are many questions, so I do appreciate that. I want to thank you again, Simon, for joining us today. It was a great value to have us on the webinar and give our audience some really great information about 802.11ax, Wi-Fi 6. So we appreciate that, and thank you very much for taking the time out of your day to join our webinar. So thank you very much for that. And I want to thank all the attendees for joining today and participating with your questions and just listening to what Qualcomm brings to the table and what EnGenius is bringing to the table. So we appreciate your time and thank you very much.
Okay.
We'll talk to you later. Thanks.